Greetings, the Astro 30 here yet again, and welcome to part 9 on this 0 to 15 volt 3 amp regulated dual channel lab power supply design that I've been working on for the last 8 or so months. And everyone is driving like a complete today. But anyway, I've been out to JCar and I've got some more goodies there. And my desk is in a complete disarray, which is one of the main reasons why I went out and bought one of these, a new toolbox. One, because I like boxes, and two, because I'm a little bit of a tool. Besides which, there are 11 bucks at Bunnings, so I thought, f it. So in this episode, I'm going to finish off the second module that I've got sitting there, just out of frame. I've got most of the hardware parts, like the connectors and stuff, to put on. The other components, like the capacitors, the resistors and the relay, etc., I've got ordered from JCar and they're on their way. Why did I order them online and pay 8 bucks for the delivery? Because honestly, I cannot be bothered crawling around on the floor in a JCar store at the component bins, trying to, you know, keep all the components in my hand at once, and, you know, I'd rather someone else do it for me. Alright, I got a plethora of plastic bags here. Okay, now, I don't know why he did that. I only ordered one red LED and he's given me a packet of 20. Okay. He did give me a bag with the parts in it. Yeah, see, I think I've got a bonus here, because here's the red LED I wanted, and I've also ended up with a spare packet of 20, which I didn't actually pay for. At least I don't think I paid for it, and the cost of what I paid doesn't add up to what it should be, because these LEDs are like $1.25 each. And if you get 10 or more, it's probably more like $1.05 by the time you get to 20. There's no way I paid an extra 20 odd dollars for these, but oh well, I've got some free LEDs. Just checking my receipt here. That would have been the last item. LED, 3mm clear red, 2800 micro candelas. So yeah, right there. He's marked it as 1, and I've ended up with a packet of 20. And the total cost was minus a $10 discount, because the loyalty program, I'd spent more than $200. 37 and 8, so it would have been 47 and 8. And if you were to add up all of these figures, that would come to 47 and 8. So yeah, I've ended up with some free LEDs. Well, it was about time that JCar starts sponsoring my channel. Anyhow, I've got a plethora of plastic bags here, connectors, header pins, etc. I've got enough to do the job. I'm going to get on with putting the connectors onto the board, and when the components arrive, I will put them on the board as well. So I've got a lot of headers. There's a lot of connectors in this project, and also in this bag I've got the last 1K 25 turn Spectrol, well, it's actually a suntan brand, but anyway, variable trimmer, because it was the last one in the box. However, it was in the wrong compartment, because I'm looking in the compartment there that's on the box. The first one was 500 ohm, the second one was 1K, and I wanted 1K. Well, there was a 500 ohm sitting in the 1K position, and well, about 10 or so 500 ohms in the front compartment. So I thought, well, like everything in JCar, maybe it's gotten mixed up. So I went through all the 500 ohms, and on the last variable resistor I picked up out of the pile, there it was, 102, 1K. I thought, yes, my lucky day. I got some 3mm LED bezels or LED clips. I did buy some hot glue as well, but I bought the wrong size. I needed 7mm, not 10. Yeah, whatever. I've got two of these red banana sockets. They are PS0420. And I've also got the companion black ones. They come in green, black, blue and red. And these are PS0421. And they're a spade type terminal connection. That's not 6.5mm. That looks like the smaller version, which is 5mm, I believe, 4.5, something like that. I don't have those connectors. I've used them. So rather than waffling on about random stuff, I'm going to start by putting, well, all the headers are in here that go on the board. So, apart from the two large ones. So I'm going to get about turning the soldering iron on and playing with myself. And I've done that already, like in the last 24 hours. Yeah. Considering I've already put the larger components on, it makes putting the connectors on a little bit more awkward, but it is what it is. This new solder roll that I'm using, the resin smells strange in it. It doesn't smell like the last roll, and it's the same brand. So it's got a very sweet sort of muffin smell to it. I don't know, that's the best way I can describe it. So yeah, the variable resistor's in, the headers are in. Until the other components arrive, that's about all I can do with that one at the moment. So now I will probably address doing some of these blasted things on the end of the other cables. I did also buy myself another packet of these cable ties, and I did actually find where the other cable ties went. They were in the bottom of a box in a bag. However, there's not many left. There was only like about 20 or so, so yeah, I've got another pack of 125, and they're colourful. I like the rainbow ones. That resin in that solder has got a lingering property to it too. I can still smell it. Anyway, before I get too excited about doing the wiring, which I'm not, I want to see if these little LED clips, which I cannot keep held in my fingers for whatever reason, these little 3mm ones, they take a 4mm hole, I believe. I want to make sure they actually fit through the panel first, and I don't have to actually drill anything out to make them fit. Would be very nice. No, they seem to fit. So I'll then see if I can pop the LED in through the other side. And there we go. I'll just take the panel off. To work on it would be easier. Yeah, I might actually just disconnect the whole entire thing, because it'd be a lot easier to work on this without it actually connected, if I can so get everything unplugged. I've now marked some of the connectors as to where they go, so I don't confuse everything when I go to try and put it back together. Because yeah, that is annoying. So I'll just pull that out. Okay, now that's the panel separated from the project. So I can now unhook everything that's all tangled up now. That doesn't belong in there. And I can move the rest of the project to the side so it's not in my way. Because it kind of is at the moment. Now, where'd that LED go? I had it a minute ago. There it is. Yeah, I've got a problem. The LED is not going to fit through the clamp because it's not actually flush with the PCB. So that means I'm going to have to size out the hole a little bit. I would have thought 4 was enough, but apparently not. So I'm going to just try 4.5. I'm going to hot glue the clips in anyway. kind of was more violent than necessary. That looks like it fits better. Okay, so 4.5 it is then. I'll try not to slip this time. Alright, find the other clip, pop him in. Alright, now I can get rid of that crap off the desk, and I can now try and pop my LED in, which is what I was trying to do in the first place. Which does not really want to go in. What size are these? Ow. 3mm. So why am I having so much trouble getting an LED to go through a bloody clip? Yeah, it fits in there. So it's the outer fingers of the clip that's not allowing the LED to clip in. Now I can't get the LED back out. There we go. I mean, yes, these are a good idea in general, but they're a pain in the ass in implementation. So get those out of the way. There we go, I did actually manage to get it popped in. It's just a bit of a tight fit. There we go, the LED's in there. How cool is that? It's a little tit. Alright, so next thing I'm going to pop in is probably the connectors for the supply output. So I need a red one and I need a black one. That's racist. Okay, I'm just being stupid at this point. Doesn't really matter. Okay, so they don't give you a lock washer on the back, just a nut, which is yeah, a bit how you're doing, but whatever. So I'll put this one in here, fits perfectly. Now I've set the width between the two connection posts to 19mm, which is the standard on most power supplies, because you can get, there's like a load resistor adapter or something you can plug directly across it, or just some form of adapter that is 19mm pitch. So this is going to be awfully awkward to get tight without it spinning around on me. So it doesn't matter if the pins are at an angle. See, like I've got a little bit of an angle to my dangle. There's a lot of wires in the way. So I'm going to hot glue the back of those anyway to stop them from spinning around accidentally. They shouldn't. So I'll just pop the red one in, and I'll do the same on the other side. And I might solder the leads to the LED to put in the second limiting position, so that yeah, I can go about starting to think about hot gluing stuff. This is starting to look cool. Alright, those two are in. Isn't that sexy? It's now starting to look more like a professional power supply and not a homemade jobby. So I'll just pop the other two in and I'll tighten these nuts up because I haven't tightened these nuts yet. So I'll make sure to tighten these nuts. And pop the other LED in, and then I can move on to doing some more wiring, I guess. Alright, I got the limit LED soldered and heat shrunk and the connector connected at the other end. I'm just going to test that the LED works. I've jammed a 10k resistor in the end of the connector, but in series with the cathode in this case. So I'm just going to turn my supply on, set currently at 3 volt, and I don't currently, well I do, that is not a red LED. That just happens to be a white one. Let's put this up to 12 volt, close to 10 volt will do. Yeah, it's a white LED. Well, I know the ones I got for free are definitely red because that's what it says on it. No, it's not, they're white. And they're only 1,000 microcandelas. He's given me the wrong bloody LED. I needed ZD104, he's given me ZD140. Yeah, that's a bit of a shame because I don't have another red LED. I don't know if the white one's going to look alright as a limit. I mean, I can always use it. Okay, so I've connected the LED to the working channel. I've got a 330 ohm resistor as a load on the output, currently at 3.9 volt, whatever. I think that will look alright as a limit LED. I'm having trouble getting it into the bloody clip though. So I'll keep working at that, trying to get it in the clip, and I might change the red one over to one of these white ones, seeing as I've got 20 of the bastards. Alright, I'll keep going. Right, I've got all the connectors, well most of them done for the other channel. Well, only the ones that are really important to the front panel, the only ones I haven't done is the larger ones for the power in and out of the circuit board. But what I'm going to do now is I'm going to hot glue around all these components to stop them from moving around. I did get the LED in. I had to ream out the hole a little bit because the clips were not quite separating far enough to allow the LED to pass through. The other side's been changed to a white one, and I'm just waiting for that to come out. I'm also waiting for the glue gun to heat up, which appears to be hot enough, so big dollop of hot snot. Do some around the switch. I don't have to go crazy with this stuff, but because I don't really have a lot of this 7mm stuff left because I got the wrong one. So I wanted to get this meter to stay where it is. Okay, I've got all the hot gluing done, and I've bunched up the low voltage control wiring with a cable tie because it's got to pass around either side of the transformer. That can stay untied, and so can the output lead, because I haven't actually got this end configured into here, which is going to pass under this bunch of wiring to those said connectors, and I have to do the same on the other side. I've got to make up the lead for it first though, and then it can pretty much go back in the case. So I went out and I've got some of these 4mm spade terminals. That's what they are. They look like 6s, not 4s. They better not be, or else I'm going to be annoyed. Son of a bitch, they're 6s, or 6.3s. However, they will actually do, so I'm going to use them. They're a bit big for the job. J-Car, their shit is all over the place. It's not funny. So I might use some non-insulated ones for this, and this is probably the last bit I'm going to do to this today, because, well, I'm still waiting on delivery of components. So gotta go find what I did with my crimping tool. Yeah, I'll just use these non-insulated ones, they'll do the job. So I need to first get rid of that dag. It needs to go around the LED, so what I might do is I'll bring the wire through where it's supposed to go, which is that way, so it's not stressing it, is I will cut the wire about there, just so it's shorter. Positive wire, well, I can cut the same length as if it was relaxed, so that can be cut as well. Okay, so I just need to trim back enough to crimp it. Doesn't have to be too much wire. Yes, I'm doing the negative first, which is the green wire, so I didn't get confused as to which black wire came out of the damn meter. Okay, so these can be a pain to use. I mean, I could have unplugged the socket. That probably would have worked better. That one there, I think it is. There we go. That's perfect. So now I just need to fold over the cable strain relief, I suppose that's what it's called. Little grip thing. Okay, I'm perfect. I've got that one done. That'll plug in just nicely to there, so I'll do the positive side one now, and I might put a bit of heat shrink over the end of each. It was kind of a waste of time going to JCar and buying that now, but at least I've got some 6.3mm crimps if I ever need them for anything. So I'm just going to heat shrink the end just to insulate it a bit. I mean, I could buy insulated ones, but they're a hard plastic and they tend to crack when you crimp on them. So just using non-insulated ones with a bit of heat shrink over the end of it's a much more preferable way that I like doing it. Do the negative side now. I've got to do this twice, by the way, for the other side as well. I haven't got to that part yet. I will shortly. It's only an extra cable to crimp. Right, so that's heat shrunk. So that can plug in. That heat shrink is hot. So that one. And that one can plug into that one. That one's still slightly warm too. That doesn't look too bad, I suppose. I mean, it will certainly do the job, so that's really all that's necessary. So what I might get to doing now is I'll do the power meter and current meter lead connector that goes to this negative socket post here, and probably the other end of it like this one, because I've got the connectors to do for that, and I've also got to do one for the mains transformer. So I've got 3 of the connectors left to do, and that's really all the internal wiring done. All I've got to do now is wait for the components to turn up to complete the other circuit board. That's all done. Everything's neatly wired in. I've even done the transformer. There's just enough clearance here. Board is fitting in there nicely. Just tidied up some wires with some cable ties. Could probably use a few more here and there. But now what I'll do is I'll see if it still even works. Okay, where's the plug gone? There it is there. Right, turn on. Apparently. This obviously doesn't work because that hasn't been completed yet, but that's fine. Voltage is still adjustable. So what I'll do is I'll need to connect up some banana plugs, which I don't have except on the other supply, so I'll just borrow them. Fits like a glove. How about that? Alright, I'll connect it up across this 330 ohm resistor, and then I'll find another load to power something in a minute. Okay, so one there. Turn the load on. Seems to be doing something. Limit light came on. Alright, so I'm not sure how much current is going across that resistor, but it's not even reading on the meter, so I'll set this to 12 volts and right, it limits. Okay, so according to my calculations, at 12 volts into 330 ohms is 36 mA, which is why it's not pickling on the meter. Because, well, it should still be pickling on the meter there, but I don't know how accurate these meters are. So I need to find something else to put across the load there. So a 1 ohm resistor, 10 watts, so I'll wind this down to a volt, somewhere there. So it's saying 800 mA, so there probably is a little bit of a discrepancy in the meter. I mean, it's not accurate. It's not the accuratest thing in the world because it's now saying 1.59 at 2 volt. It should be more closer to 2 amps. And I don't believe there's an adjustment on the back of them, I can't remember. But yeah. I mean, it works, it gives you an idea though. So I want to check the other transformer winding now, just to make sure there's continuity through the cable. Yeah, well, that doesn't look very promising, does it? Let me just measure across the connector. There we go, 16 odd volt. So yeah, that side's working perfectly fine. And the top cover fits on semi-perfectly. Once the screw goes in it, it'll come down nice and flat. So yeah, that's looking pretty good right about now. Well, within the last few seconds, and a couple of weeks for me, I've now got all the components I need necessary to complete the other channel of this 0 to 15 volt power supply project that I've been working on. Got the heatsink, got the ICs and the output transistor, and some 15mm M3 screws, which I have needed for a while. So what I'm going to do first is I'm going to pop the 555 timer into where it goes, and I'm going to first test, before putting the output stage on and the op amp, I'm going to first test that I've actually got the 3.3 kilohertz roughly square wave signal at the output, and then make sure that I've got the DC minus 5 volt here at pin 4 of the op amp with respect to the common. And I might use a DC power supply to inject my voltage into here first, just to make sure that there's, you know, no serious issues. Okay, everything's set up. I've got the positive lead of my other power supply going to the positive of the bridge rectifier. The negative is being backfed up the circuit through the common, which is fine because this these two current sense resistors are on the positive rail of the output. Ooh. I've got the oscilloscope ready to go. I'm going to probe pin 3 output, which is just here. So I'll turn the supply on, and I'm at 5 volts currently, but there's no unusual current draw, so that looks fine. So I'll wind it up to 15.6. Man, that fart stunk. Right, so I'll probe pin 3. We do have a signal. It's too large. There we go. We've got a square wave, approximately 2.82 kilohertz. It's not quite 3.3, but that's fine. So I know that I've got a voltage, well, an oscillation there, which is what's supposed to be happening. So we'll look at the multimeter, and I'll just grab my probes. Now I want to see if I've got a negative 5 volt reference to the op amp between it and common. For some reason I don't appear to have a voltage. It is kind of annoying when you can't remember how your own damn circuit works. I was only getting like 3 volts across pins 8 and 1 of the 555 timer. So yeah, that's not going to work. It needs to rectify half wave of the AC coming in of the transformer. So I've hooked the board now up to the transformer. Nothing should go bad. If it does, it'll just blow the inline fuse. So I'll turn it on and we'll look at the oscilloscope trace again. Right, I've turned it on, nothing went bang, so I'll just probe that pin 3 output again. Yeah, we still have a square wave. So across the IC itself. Pin 4 is over here, not over there. Just so I'm not going mad. There we go, there's our negative 5 volt reference. Okay, after all that kerfuffle, I now know that this circuit works, and in fact, if I can find which one it is, so it's the black and orange. I want to see if this one, I want to see if the power LED works. So that should be that one. Oh yes, nice, we now have a power LED. Okay, cool. So the next thing to do is to build the output stage. But first I'm going to drill the heatsink so it can be mounted to it. And then we can screw it onto the back panel. I can tighten all the screws up, put the components in correctly how they are supposed to be, and connect everything up. This is exciting. That's the heatsink drilled, and these holes do, to a point, line up with the holes on the aluminium back panel. So that's fine. So what I'm going to do now is I'm going to attach the PCB angle brackets to the heatsink, tighten them up so I can tighten these 2 screws on the PCB, pop the devices in, the transistor and the LM317T, solder them in so they're in the right place, take it all back apart, and actually apply it to the back panel. So I'll get to doing that. Alright, the devices are now soldered, and I've dropped the thing twice on the floor, which is starting to piss me off. Bent these resistors at a little bit of an angle, but that's alright. Everything fits. I had to massage these holes because they were wrong. They probably are still wrong. But now I need to find the isolators, and I can now assemble it to the back panel. Right, well that was a struggle for no reason at all, only just because things don't line up, like the holes didn't line up. So now I will start connecting up this board. So we've got the AC there. Now, that I believe is an LED. That's for the meter. That's our output. So that goes over here. That I don't know right now what it is. That's the limit LED. That's the voltage pot. That must be the current pot. brown, yellow, white. Yes, so that's the current pot. Now we have a power LED, which is this one, so that goes over to here. And I've marked the switch, so that goes to here, and that is our load on off LED. Okay, beauty, all wired. Now I guess it's the moment of truth. It's all wired up, the op amp is in, so I'll start with that down low, and I'll just find my power plug. If there's anything majorly wrong, it'll just blow the line fuse, as I've already previously stated. Turn him on. We've got an output. It says 0.6 of a volt, that's only because it hasn't been zero adjusted. But the voltage does indeed increase. Alright, so I'll put that back to zero because I've got to zero it. Load on off works. Box of birds. Alright, so let me connect a multimeter to the output and I'll just zero it. Right, so I've just got to get into this pot. Trim pot. That's the wrong way. And we're going down, going down, going down. Menswear. And there we are, roughly somewhere. Ooh. Come on. Come back up. Went too far. Way too far. Yeah, still not quite zero. It's kind of annoying. I mean, a few millivolts is alright, I suppose. But I want to try and get it as close to zero as possible. And it just came back up again. Bloody thing. Alright, that I'm going to say is close enough. So I'll just turn the pot up. All the way. We're at the full voltage now, and I reckon this is jumping around because my leads are not making good contact. Okay, so I'm just going to fix that. Okay, so now it's time to test the functionality. So I've got it set to 1 volt. I'll bring the current limit right off. Well, okay, these leads aren't making good connection. There we go, it's limiting to 600 mA, and we're roughly the same as the other one. So I'll bring it up to 2 volts. Which is about there, and we've got close to 2 amps of current draw. Nice. So, very good. So it is working, it's delivering current. So now I need to fix those leads, they're shit. So now I can put the top on and screw it down for the last time. Now I don't have any of the knobs for the controls, but for this project, to get it to completeness and actually functioning, I don't actually need the knobs. So I can get them like next week or something. So I'll just go find the screws for the case lid and we'll screw it together. Found the screws. Okay. Don't need to do anything more inside, so I'll just turn him upside down and kick the tripod for the 100th time. Put the screws in. sure everything's still lined up. It is. Alright, so it's fine. And there we go there. She is now a complete unit. Doesn't that look sexy? It'd look even better with knobs on it. But yeah, I'll just plug him in again. Turn everything on so it looks pretty sexy. I'm going to use that as a thumbnail. So yeah, there is the bench supply complete, apart from the knobs. So this has been a journey. It's taken me several months, probably 10 or so months now. And I'm glad that you guys came along with me. So I'm going to end this video here. I hope you enjoyed it. Please remember to rate, comment and subscribe below if you haven't done so already. And this is the Astro 3 saying see ya, have a great day, I'll see you in the next one.